Hey guys, so today we are going to go ahead and talk about scientific notation, which is cluster 6, day 6 notes. And basically, scientific notation is used to be able to represent a number that's really, really big or really, really small. So, for example, let's say you're doing some kind of a work in astronomy or NASA or even medicine, where you might be looking at some kind of a item and it's really really small because you use a microscope, and of course whatever the object that you're looking at, whether it's really big or really small in size, it has a measurement. And of course, if you're writing information down, you don't want to be writing this number over and over again and writing out zeros, this many zeros over and over again, because you have to write this number multiple times. Because chances are you're probably going to leave off a zero somewhere. Or if you have a really, really small number, a really, really small decimal, you don't want to be writing all these zeros over and over every time you're going to write down this number and then make a mistake. Okay? So, scientific notation is used to be able to convert these numbers into something that's a little bit easier to read. Okay? So, what we're going to do today is we're going to take numbers, convert them into scientific notation, and then take scientific notation numbers and go back to standard form, which is just basically back to their normal uh, form. Okay? So, scientific notation is a special format, and it's always some kind of a number, okay, that is always between 1 and 10. Okay, so it can be 1, 2, 3, 4, 5, 6, 7, 8, okay, or 7, 8, and 9. And basically, it could be just a regular number, it could be a decimal, it could be 1.17 or whatever, but the number is always between 1 and 10. And then the format is always times 10 to the power of something. And that's the exponent that will tell us the placement of the value of how big or how small the number is, okay? So we're going to start off by taking this scientific notation and converting it back into standard form, which means just a regular number. So if I take this front number 1.5, I'm going to move my decimal 5 times because that's what my exponent tells me. The exponent is telling me the place value of my number. Okay, so basically it's telling me to move my decimal 5 times to the right, and it's right because it is a positive exponent, and positive numbers are to the right. Okay, so here we go: 1, 2, 3, 4, 5, and then you put your decimal. Okay, and these empty humps, I'm just going to put zeros in them. So there's my number. So it's 1.5 times 10 to the power of 5. It's actually 150,000. Now let's add some commas. And there you go. 150,000. Okay? Now let's try the one beside it. Now we're going to take this scientific notation and we're going to convert it back to a regular number or standard form. But if you notice, the exponent this time is a -5. So this time, instead of going to the right side, we are going to go to the left side. So I'm going to get 1.5, and my exponent is telling me to move my decimal 5 times to the left because it's negative. So that's 1, 2, 3, 4, 5. Put a decimal there. And so if you add zeros, that'd be 1, 2, 3, 4 zeros, and there's your decimal. So basically, my number is 0.000015. Okay? So anytime you have a positive exponent, it's going to come out to be a really big number. If it has a negative exponent, it's going to come out to be a really small decimal number. Okay? Now let's take these regular numbers, which are in standard form, and let's convert them back to scientific notation. Okay? So first thing I'm going to do is, let's start off with the really small decimal, okay? If you notice, the decimal is already given to us. So what I'm going to do is I'm going to take that decimal and I'm going to keep moving it, okay, until I have one digit in front of that decimal. And it has to be a digit that's between 1 and 10, okay? So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And I'm going to stop between 1 and 5 because all I need is one digit in front of the decimal that falls between 1 and 5, okay? And so here we go. If I write that out, I get 1.5. And remember, the scientific notation format is always your number times 10 to the power of something. Well, if you notice, I'm going to count how many humps I have. Okay, so that was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that's going to be a negative 12 because it's a really small decimal. And remember, when we have a really small number that is a decimal, it has to be a negative exponent. Now let's go to the next one and let's convert this example or this regular number, which is in standard form, into scientific notation. So if you notice, there is no decimal that they gave me. So if there's no decimal in the actual number, just go ahead and put it at the end, okay? And now I'm going to keep moving my decimal and I'm going to stop until I have one digit in front of that decimal that is between 1 and 10, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and I'm going to stop there. So you see, so I'm going to have 1.5 times 10 to the power of 12 because it was 12 humps, and it's a positive 12 because this was a big number. Okay. So these are the four different ways that you can convert. So now what we're going to do is we're going to go to the next page and we're going to do a couple examples. Okay. And so this is what the IXL is going to be on. So here we go. Let's start with number 1 all the way up here. We're going to convert each scientific notation into standard form. So they want us to convert it into a regular number. So what I'm going to do is I'm going to take my number 7.1 and I'm going to move it 3 times to the right because I have an exponent of 3 that is positive. So that's going to be 1, 2, 3. And there's my decimal. And so I'm going to add 0, 0. So really my number is 7,100. So 7,100. And I know you might say, well, Mr. Gomez, what about the decimal? Can we just put it at the end? You can, but really it's just going to be there. So there's really no purpose for it because if we put a decimal there, there's no other numbers behind it. So really there's no need. Okay. So another way to think about it, think about money. If I have $4, do you usually say 4.00 to say $4? No, you might just say $4 because it's implied. Okay. Because there's nothing else behind that. But yes, we know we can write it out as 4.00, but it's not needed. Same idea here, okay? Let's move on to number 5. 3.21 times 10 to the power of negative 4. Well, if I take my number 3.21, it's telling me to move it 4 times to the left. 1, 2, 3, 4. Put your decimal. Put a zeros in each hump that's empty. And let's write it out. So my number is 0.000321. And this is the standard form of that scientific notation. Okay. Let's try number 6. Number 6, we have 6 times 10 to the power of 5. There's no decimal, so I'm going to put it at the end. And now I'm going to move my decimal 5 times to the right. 1, 2, 3, 4, 5. And so I'm left with add zeros into each hump. And so that gives me 6, 0, 0, 0, 0, 0. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay? And there you go. You can add commas if you want to. And that gives me 600,000. Okay? Let's try number 17. Or sorry, not 17. Number 8. Okay, so we have 1.7 times 10 to the power of 12. Now, this is a perfect example of why scientific notation is needed. Because look at how nice this looks. Now, let's convert that number into standard form. So I'm going to say 1.7, and it's telling me to move the decimal 12 times to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's add all those zeros. Look at that. And now let's write out our number with commas. So we have 1, 2, 3. Okay, let's do 1, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's add some commas so we can be able to see what kind of number we have. So that's hundreds, thousands, millions, billions. Oh, we have 1,700,000,000,000. Okay, that's a big number for us to keep writing over and over again. So you see the difference? How easier it is and how nicer it is if we write it out like this versus this. Okay. Now let's do number 9. Whew, it's telling us to move the decimal 17 times. Okay, I'm not going to do that. Actually, I am. Let's go for it. And it's telling me that we have 8.653, and it's telling me to move it 17 times to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Add zeros in each empty spot. So now here's my final number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 8, 6, 5, 3. There you go. You see, this is a scientific notation of this regular decimal number. Okay, so you see, scientific notation can be very useful, especially for careers that are dealing with really, really big numbers or really, really small numbers, because you don't want to sit there and keep repeating and rewriting that same huge or really small number over and over again. Okay, now let's go ahead and do part 2. Part 2 basically says write each number in scientific notation. So what we're going to do is we are just going to skip 10 and 12, and we're just going to go ahead and do 17 and 18 down here. Okay, so here we go. So we have this really big number. Since I don't have a decimal, I'm going to put it at the end, and I'm going to move it enough times until I have one digit in front of the decimal that it is a number between 1 and 10. Okay, so here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I'm going to stop between the 2 and the 3 because I just need one number or one digit in front of the decimal. So I'm left with 2.36. You don't have to include the zeros. Times 10 to the power of, so how many times did we move it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And it's a positive 11 because it was a really big number. So there you go. So you might say, well, Mr. Gomez, why didn't we add the zeros? They're not needed. They're implied to be there. Remember, because once we move that decimal and we get those humps, we're going to have to put zeros there anyways. So that's why there's no need for us to include all those zeros. What I do need to include is the 2.36 because those numbers are not implied. Okay? Let's move on to number 18. If you notice, I do have a decimal. So I'm going to keep moving that decimal until I have one digit in front of the decimal. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so that will give me 2.36 times 10 to the power of negative 13. But let me double check. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13. Yep, and it's a negative 13 because it's a really, really small number. Okay, so there you go. If you have any questions, make sure you're welcome to send me a message, an email, or a text message. Okay.